Why does science work? What do I mean by that? You see, we take chemistry and biology and especially physics for granted. Science has given us incredible inventions and insights into the universe and the way that nature works. But consider physics for a moment. Lying behind physics, the more physics we do, the deeper we peer into the solar system and into the fundamentals of the universe, we discover these incredibly beautiful mathematical equations powering physics, the laws of physics that describe how our universe works. Everything from the orbit of electrons to the formation of galaxies and stars and so on and so forth.
No, we don't discover them. We formulate them as a means of communicating apparent regularities.
Now that raises a question though. Why is it that mathematics and physics fit so perfectly well together? Why do numbers plug so well into the laws of physics?
Because numbers are the language in which we communicate many concepts in physics. People who ask this question are essentially saying, this description matches the thing it describes. What a weird coincidence. Clearly there's a god involved somehow. Descriptions match the things we describe because we formulate those descriptions for that specific purpose. This is not a coincidence, nor is it evidence of a god.
But what's the problem? Well, here's the problem. If you're an atheist, what is mathematics? What are numbers? You see, if you're an atheist, you have to recognize that numbers don't really exist, right? Numbers were just something invented by Mesopotamian goat herders sometime around the 2nd millennium BC to keep track of how many sheep and goats they had. They're just a kind of human counting system. But if that's the case, how is it that those things invented all those years ago, just that human invention, can describe everything from the curvature of space-time to the interior geometry of black holes or the probabilistic equations powering quantum physics? It makes absolutely no sense.
Oh, this argument again. Math is a language. It is a thing we use to describe observations. Saying that the descriptive utility of math implies that it is inherent to the universe is like saying that the descriptive utility of English implies that the English language is inherent to the universe.
How is it that maths and physics fit so well together? Did those goat herders just get very, very lucky? Or is something else going on?
Do you really need to be lucky to make a description match the observations it describes?
And in fact, a very famous mathematician called Eugene Wigner, in the middle of the 20th century, wrote a groundbreaking paper called The Unreasonable Effectiveness of Mathematics, in which he sets this problem out. And in one sense, it's never been answered. A more recent, a contemporary astrophysicist called Paul Davies put it this way. He said, this is one of the deepest mysteries at the heart of science. Why is physics shadowed by mathematical reality? Why does theoretical physics work?
Here's my hypothesis about why this is the case. Sometimes you can make a mathematical inference that looks like an empirical prediction, when really what you're doing is unpacking something conceptually inherent to a mathematical description of what is already observed. For example, let's say you're building a truss for a roof. You can usefully describe the shape of the truss as 2 right-angle triangles. If you measure half the bottom beam as 4 meters and the vertical beam as 2 meters, you can use Pythagorean theorem to calculate that the length of the diagonal beam will need to be cut to about 4.47 meters. Now, if you cut the diagonal beam to that length and it fits, Andy would say, what a coincidence! The mathematical prediction matches empirical observation. Clearly a god must have placed math into the very essence of the universe itself. There's no other explanation for this effective application of mathematics. The thing is, though, that no real prediction has been made here. If you describe the truss as 2 right-angle triangles, and you describe half the bottom beam as 4 meters, and the vertical beam as 2 meters, you are already describing the diagonal beam as being roughly 4.47 meters. You're not predicting what the length will be, you are already saying what it will be when you give values to the other measurements. The length of the diagonal beam is already conceptually inherent to the description you've already made. This looks like an effective empirical prediction, but really it is nothing more than a description that gives the illusion of prediction. Thanks again for helping me out on Patreon.